Everyone. Today's class is current electricity. Very easy topic. We have to know all the concept step by step. Please see. Current electricity. First, here we have to know. Here is charge, and this charge is moving in this direction. Suppose this charge is Q and this point is A, and sir, this point is B. My question is, this is the charge, charge is moving in this direction. Which is the direction of current? Maximum students will give answer this. If charge is moving in this direction, sir, this is the direction of current. It is not absolutely correct. Answer is, if this charge is negative charge, in that case, sir, direction of current in this direction. But suppose the charge is moving in this direction from A to B, A to B, A to B, in that case, sir, current is also in the same direction. Here I indicates the current, and this Q is the charge, so this is also current. Okay. Now what is the rule? For positive charge, charge and current have the same direction. For negative charge, for sir positive charge, Q positive, then sir Q and I have same direction, Please see, this is one. For negative charge, for Q equal to negative, then what is the rule? Then negative charge, then charge and current, sir, have opposite direction. Opposite direction. What is the rule? For positive charge, current and charge have the same direction. For negative charge, sir, current and charge have opposite direction. Now, here one thing is important. What is the unit of charge? That is very, very important. Unit of charge. Here is 1, 2, 3 ESU of charge. Second is coulomb, and third is, sir, EMU of charge. Be careful. Here, what is the full form of ESU? ESU, electrostatic unit. What is EMU? Sir, electromagnetic unit. Here is one rule. In downward direction, arrow is downward direction. What is the meaning? Sir, coulomb is greater than ESU and EMU is also greater than coulomb. This ESU, this is known as stat coulomb. EMU known as ab coulomb. Here, sir, coulomb, 1 coulomb greater than 1 stat coulomb. 1 stat coulomb. 1 coulomb greater than 1 stat coulomb. Question is, how much greater? Can you tell me? 1 coulomb is how much stat coulomb? Please Be careful. This is the basics of this chapter. 1 coulomb equal to, sir, 3 into 10 to the power 9 stat coulomb. 3 into 10 to the power 9 stat coulomb. Another thing, what is this? Sir, 1 app coulomb, that is EMU, app coulomb, that equal to, sir, 10 coulomb. Now what is this? This can be written, sir, 10 into 1 coulomb. Please see, what is this? 1 coulomb equal to 3 into 10 to the power 9 stat coulomb. What is this? Sir, 3 into 10 to the power 10 stat coulomb. I am writing in short, stat coulomb. Therefore, what are the relation? Please see here. Again see, 1 app coulomb directly, sir, 10 coulomb. This is one rule. Before that, sir, 1 coulomb equal to 3 into 10 to the power 9, sir, stat coulomb. This is important. Okay. Next thing is, here is one small formula. I, this is Q, and from here to here, sir, time, what is this? This is the time. Suppose this time is T. What is the relation among 3? This is equal to Q into YT. So what is this? This is Q by T. Can you tell me? When it is stat coulomb, and in every system this is 1 second, this I is called stat ampere. Stat ampere. What is this? Sir, 1 stat ampere, that equal to 1 stat coulomb. This is 1 stat coulomb divided by 1 second. Actually, heading is units of current. What is this? ESU of current, and this is ampere, and this is EMU of current. Now one thing is important. Ampere, this is ESU of current, electrostatic unit of current. This is EMU of current. Ampere of current. Ampere of current. This is wrong. Of current is not used here, because ampere, it is the only unit of current. It indicates only current, but ESU can indicate potential, resistance, capacitance. Similarly, EMU can indicate potential, resistance like these, but only ampere, it is used for current. It is used for current. Therefore, here of current is not used. Same relation. What is the relation? Sir, in downward direction, bigger unit. Ampere, 1 ampere greater than 1 ESU of current, 1 EMU of current greater than 1 ampere. As ESU current, this is also written as ampere. I am deleting. Please see. I am deleting. Stat ampere, and this is also ampere. ab ampere. Rule same. What is the relation? A relation, please see, relation between ampere and sir state ampere. State ampere. What is the rule? 1 ampere equal to 3 into 10 to the power 9 ESU of current or state current, state ampere. State ampere. Similarly, sir, 1 EMU of current, this is equal to what? Sir, this is simple 10 ampere. 10 ampere. We can write, sir, 10 into 1 ampere. Please see, 1 ampere. This 1 ampere equal to what? 3 into 10 to the power 9. Now put here. What is this? Sir, this is 3 into 10 to the power 9 state ampere. I am writing in short. What is this? Sir, this is 3 into 10 to the power 10 state ampere. The unit is very, very important in this chapter. Now, please see. Here, this circuit is very, very important, simple. This is the first circuit in this chapter. Here is one E and R. This is equal to what? In short, this is EMF. What is the full form? Sir, this is electromotive force. And this is, sir, internal resistance. Internal resistance. See here. Here is capital R. Capital R. This is, sir, external resistance. External resistance. Why, sir, external or why internal? This is known as, in short, in some case, simple case, it is cell. In bigger case, sir, it is battery. This R is inside the cell or inside the battery, and outside the cell, therefore external. Outside the cell, external. This whole thing is the circuit. What is the spelling? Circuit. This is the circuit. E electromotive force of the cell. This internal resistance. Here, please see, sir, this bigger hand, I am deleting this part again. Please see. What is this? This is EMF. This is the bigger hand. This bigger hand acts as positive electrode. Positive electrode. And this smaller hand, sir, this is negative electrode. Negative electrode. Here is one rule. What is the rule? In the circuit, current will flow from bigger hand, and it will enter into the cell or battery from a smaller hand to bigger hand, but outside the circuit, the direction of current from, sir, bigger hand, that is, sir, positive electrode, and this is known as, sir, current. Actually, sir, this is main current. What is the formula? Simple formula. Sir, I equal to E small r divided by capital R plus capital R. Now, here is, I am deleting this portion. This is the current. Here and here, these 2 points, suppose this is A and this is B. Potential difference between the point. What is this? This is potential difference between A and B. What is the formula? This potential difference, what is the formula? Sir, VAB, sir, I into R. Potential difference I into R. That potential difference is also in between two electrodes. This here is also this VAB. And what is the formula? Here is formula, sir, I into R. Here is formula E minus IR. Please see here. Potential difference between two electrodes. What is the formula? Potential difference between two electrodes. Electrodes that also equal to VAB, and this equal to, what is the formula? E minus IR. This IR has a special name. Can you tell me what is the name? IR has a special name. What is this? This is potential drop. This is potential drop. This is equal to, sir, potential difference. What is the unit of this potential difference? It has unit. This is known as volt. Therefore, this portion has extra name. Sir, this is lost volt. This is lost volt. Potential drop, lost volt. Now, see here. Suppose here is one cell, this is another cell. They are connected by external resistance. This is EMF R1, it is E1, this is E2, this is O2. Here, please see, two cells. What is the rule? This cell will send current in this direction, this cell will current in this direction. They have the same direction of current. In this case, two cells are helping each other. What is the formula of I? Sir, formula of I is E1 plus E2 R1 R2. This is the formula of main current. Main current. Okay. This is the formula. Here is, sir, here is potential difference V1 that equal to E1 minus IR1. Here is potential difference V2. What is this? Sir, E2 minus IR2. Here is potential difference. What is this? This suppose A and this is B. So here VAB that equal to, sir, I into R. This is one formula. Another formula, this VAB equal to this V1 plus V2. V1 plus V2. Be careful. VAB equal to I into R, and that VAB is equal to V1 plus V2. In this case, here this part is the potential drop, here is potential drop. Suppose I am giving one question. Question is, R here R equal to, sir, 5 ohm, R1 equal to 0.5 ohm, E1 equal to 2 volt. Unit of electromotive force, that is volt. Suppose R2 equal to again 0.5 ohm, and this E2, this E2 equal to, suppose 4 volt. Now question is, first we have to calculate I1. Second question is, sir, V1. Third question is, sir, V3. Please see here. Since two cells are helping each other, what is the formula? Sir, this is the formula. Please take E1. What is E1? Sir, 2. What is E2? Sir, this is 4. This is 0.5. R2 is also 0.5. And R, what is R? R is 5. What is this? This is 6. This is divided by 6. So what is this? This is 1 ampere. 1 ampere. I equal to, sir, 1 ampere. What is V1? Sir, this is E1 IR1. Please see here. E1 IR1. What is E1? Sir, this E1 equal to 2, I equal to 1, R1 equal to what? Sir, 0.5. Now what is this? This is 0.5. What? This is 1.5, sir, volt. What is V2? Sir, this V2 equal to E2 plus I or 2. What is it? What is E2? E2 equal to 4 and I equal to 1, and this is, sir, 0.5. What is this? Sir, this is 3.5 volt. Okay. Suppose here, please see, what is this VAB? Sir, this VAB equal to, I equal to 1, R equal to, R is here, sir, 5. What is this? This is 5 volt. Okay. From here, V1 equal to what? Sir, V1 equal to 1.5 and this is 3.5. Please see, again 5 volt. Therefore, we can say this VAB equal to IR and same VAB equal to this potential difference plus this potential difference. Be careful. In some question, directly, suppose I am writing this. Please see here. In this case, other things are not given. Only this part is given. Here V1 equal to, suppose 5 volt, and here V2 equal to, sir, 7 volt, and question is, sir, this potential difference. This is the potential difference. In this case, sir, resistance or current, nothing given. What is this V? Sir, this V equal to V1 plus V2. What is the answer? Sir, this V equal to V1 plus V2. This equal to 5. This is 5 volt plus 7. This is 12 volt. Be careful. Okay. Now, I am giving another figure. This is important. Sir, in this case, please see, in this case, see here, it has tendency, in this case, it has tendency to send current in this direction. In the same circuit, two directions are not possible. Here we have to see E1 R1, E2 R2. Suppose this is R. I am deleting this part. I am deleting. Please see. This is E1, this is E2. They have tendency to send current in two directions, in this directions and in this directions. In this case, and suppose here V1 potential difference, here V2. In this case, which will be the direction of the main current? There will be single direction. That direction depends on direction I. In this case, I depends on number one, sir, and R. Number two, R1 and R2, number 3 V1 and V2, and number 4 E1 and E2, E1 and E2. What is this? Direction of I. What is the answer? Sir, direction of I depends on R, R1, R2, V1, V2 and E1, E2. Sir, what is the answer? Answer is E1, E2. In this case, I am taking, let E1 greater than E2. In this competition, you will win, and in this case E2 will be defeated. In that case, since E1 is greater, the direction of current will be this, and its property is lost, means in this direction there will be no current. When it is lost, it is the direction of this. In this case, what is the formula? What is the rule? Since in this case two cells are opposing each other, here what is the formula of I? Here formula of I, bigger EMF minus smaller EMF. Bigger EMF minus smaller EMF, but all the resistances will be added. This is one rule. Here will be added, but here will be difference. I am putting 3 star here. In case when two cells or two batteries are opposing each other, we have to see which is greater, E1 or E2. I am taking E1 bigger. I am taking E1 is bigger. Therefore, this will be the direction. Or in this case, what is the formula? Higher EMF minus lower EMF divided by whole resistance of the circuit. Okay. Now, here is question. In this case, sir, this is, in this case, suppose this is A, this is B. What is this? Sir, this is VAB. What is the formula of this? I am writing, please see here, this VAB. In this case, I am deleting this part. I am deleting, there will be confusion. Please see in this figure, what is this? Sir, first thing, sir, this equal to I into R. Another formula, this VAB equal to this V1 minus V2. Be careful, here is the minus sign. This is the minus sign. Okay, I am giving the example. Please see here. I am giving the example. Suppose here for this figure, E1 equal to 10 volt, E2 equal to suppose 7 volt, this is 7 volt, R1 equal to 0.1 ohm, R2 equal to suppose this is 0.9 ohm, and R equal to I am taking R, capital R equal to suppose 5 ohm. Please tell me what is the I equal to what? I am putting here I equal to, please see, E1 which is bigger, 10 minus 7, this is 0.1, this is 0.9, R2 9, and this is 5. What is this? This is 3, this is 6, that is 1/2 ampere. Okay. According to this formula, sir, what is VAB? What is VAB? VAB, see here. This VAB equal to I into R. What is I? 1/2. What is R? Sir, this is 5, this is 2.5 volt. Be careful. Now, here R. Sir, V1 equal to, sir, E1 minus IR1. But here, see here, sir, this equal to I plus IR2. V2 equal to E2 plus IR2. What is the formula? Sir, V1 equal to E1 plus minus IR1. What is E1? Sir, this is 10. What is I? Sir, this is 1 by 2. What is this? R1. R1 equal to 0.1. Okay, I am taking, sir, this is 10 minus, what is this? This is 0.05. 0.05. So what is this? Sir, this is 9.95 volt. 95 volt. V1 equal to what? 9.95 volt. Now please see here. What is V2? Sir, V2 equal to, sir, E2 plus IR2. What is E2? E2 equal to, in this case, E2 equal to 7. This is 7. I equal to 1 by 2 and R2 equal to 0.9. This is equal to 7 and this is 0.45. What is this? Sir, this is 7.45 volt. Now, please see here. Another formula VAV equal to V1 minus V2. Please see. I am deleting this part. I am deleting this part. What is V1? Sir, this is V1. Sir, this is 9.95 and V2 equal to 7. This is 7.45. What is this? This part is this and this part this. What is the answer? VAB. What is the formula? 2.5 volt and this is also 2.5 volt. Be careful. When two cells are opposing each other, in that case this VAB equal to simple this minus this. I am giving one example. Please see. Suppose this is the circuit, this is R. This question is very, very important. Suppose here V1 equal to 10 volt and here V2 equal to 3 volt. Be careful. And question is, this is A and this is B, this is R. R has no value. In this case, the value of R is not given. Question is direct question. What is the question? Sir, VAV. What is the language? Sir, potential difference between the points C, between the points A and B. This is the question. Simple, this is the answer. These two cells, it has direction, this has direction. What is the ultimate direction? Sir, this direction, this potential difference is bigger. So, ultimately direction will be here. What is VAB? In this case, VAB, V1 minus V2. E1 R1, E2 R2 and value of R, nothing given. Direct, this is the question. What is the question? V1 minus V2. VAB, potential difference between the points A and B. Sir, direct answer. What is the answer? V1 minus V2. What is this? Sir, this is 10 and sir, this is 3. What is this? This is 7 volt. This is 7 volt. Okay. Now, in this case, since in this case, this is bigger, this is smaller, current is in this direction, not current in this direction. This is one rule. Another thing is important. This cell or battery, this is charging. This is charging. Be careful. And this part is discharging. Discharging. Suppose there is no electric supply, battery is being used. After some days, battery will be charged up, the battery will be lost. When this battery is taken to give the charge, what is the rule? This battery will be put here and this charging battery, this is the charging battery, this battery is charging this. This is discharging or this battery is being charged. In that case, sir, we need, suppose I have a battery, its EMF is 7.5 volt and this EMF is lost. When it is lost, the battery will be again charged. When it will be charged by another battery, that battery should have EMF more than 7.5 volt. Suppose more than 7.5 volt is 10. In that case, this 10 volt battery will charge this battery. This 3 volt battery will not charge this battery. I am giving one question. Please see here. Suppose, simple, this is the rule. What is the rule? Here is some resistance, EMF, this R, current is moving like this. This is the direction, this is the R. What is this? This is the V. What is the formula? We have seen. In this case, by this battery, this resistance, suppose here is TV, here is light, here is fans, there are so many things, total resistance is this, means with the help of this battery, all are functioning. When the EMF of the battery will be lost, here will be no lighting. In this figure, this battery is being discharging. Please see here. In this figure, this battery is being discharging. Discharging, we are getting charge. It is a simple formula, sir. I equal to E this, and this V equal to, sir, E minus IR. Now, when I am drawing this figure, please see this. What is this? This is a small hand. I am taking, so this is E1 and this is E2, and suppose E2 greater than E1. It has R1, it has R2. Suppose E2 greater than, let I am taking E2 greater than E1. E2 greater than E1 means current will be this current, this direction, there will be no direction. In this competition, it is defeated, it is this public gain. What is this? In this case, sir, this is the current. It is in this case, sir, discharging. In case of discharging, what is the V? V equal to, it is V2, this equal to E2 minus IR2. In case of charging, this is R. In case of charging, be careful, E1 minus I, this is R1. What is this? When current moves inside the battery from negative to positive, it is taken as positive current. But when inside the battery from negative to positive, it is taken as negative current. This minus this equal to E1 plus IR1. During charging, what is the formula? V1 equal to E1 plus IR1. I am asking one question. Please be careful. The relation between E and V, EMF, and this is the potential difference between the two electrodes. What is this? Sir, this is the potential difference between the two electrodes. The relation between E and V, E greater than V, E equal to V, and E less than V. Which one is correct? Answer all. Which one is correct? The relation between E and V, out of the three, E greater than V, E equal to V, E less than V, and that is all. Which one is the correct answer? All the three are correct. I am giving example. Here answer is all. Sir, when In this case, it is, be careful, this is discharging. During discharging, this is the answer. It is used in a special case, I will discuss later on. Please be careful. Potentiometer. Potentiometer is equal to V. And E less than V, this is charging. This is charging. Be careful. I will discuss this part later. This is very important topic of this current electricity. We have to know potentiometer in details. This is charging, E less than V. This is discharging, is E greater than V. Please see here. In this case, this battery, this is being discharging. In this case, please see here. Sir, this is discharging, this is discharging, this is discharging. This is discharging and this is being charging. In this case, what is the formula? In this case, V1 equal to U1 plus IR1. So what is the rule? In this case, sir, V1 less than U1. Sir, V1 less than, this is not V1, not, this is answer. Sir, this is V1 greater than U1. What is this? V1 greater than E1, or you can write, sir, E1 less than V1 during charging. During discharging, what is this? Sir, this is V2 equal to E2 minus IR2. Here, sir, what is the rule? Here in this case, sir, V2 less than E2, or in other words, sir, E2 greater than V2. I will discuss later on. Sir, potentiometer. Today, E greater than V discharging, E less than V during charging. I am giving one question. Please see here. There are, please see, here are some cells, identical cells. What is the meaning? All have same, sir, 2.5 volt. All have R, that is 0.1 ohm, all. But how many cells are there? All the cells are in series connection. All the cells are in series connection. Here, charging current, please see, charging current equal to 8 ampere, this is given. Charging current, this is 8 ampere, and these cells are being charged by a 200 volt battery. This is the 200 volt battery. 200 volt battery. Question is, what maximum number of cells? This is N max, maximum number of cells can be charged. This is the first part, first question. This is N max. Next question is, what extra resistance is to be put in series, that is important, in series with the cells, This is the second part. Please be careful. Here, first thing, number N max, I am putting, this is 55, this is 60, this is 65, and this is 4, sir, this is 70. Maximum number, which is correct. N max equal to what? 55, 60, 65, 70. And what is R? I am putting R. What is this? This is again, this is 1, this is B 1 by 2 ohm, this is C 1 by 3 ohm, and this is D, sir, 1 by 4 ohm. Please see here. Charging current 8 ampere. All the cells are identical. Each cell has EMF 2.5 volt, internal resistance sir 0.1. These cells are being charged by a battery of 200 volt. Question is, what maximum number of cells can be charged? First part, and second part, what extra resistance is to be put in series with the cells? Okay. Now, these are the questions, 2 questions. I am deleting this part, please be careful. Since this is these cells are being charged, now please see, these are the bigger hand, current will be sent in this direction. Since this is in this direction, what is the potential difference between each cell? Here is important. The cells are being charged. What is the formula? Sir, E plus IR, not minus IR. What is this? Sir, this is 2.5, this is sir 8, and this is 0.1. This is 3.3 volt. Okay. Now, they are in series. Therefore, sir, what is this? Sir, this is N into how much? 3.3. This should be equal or less than, not greater than, that equal to 200. Suppose I am taking, what is this? This equal to or less than this divided by this. Be careful. This is 60.6 like this, but 60.61. What is this? In this case, can you tell me what is this N max? From this N max, according to mathematics, when it is more than 5, it is taken as 61. But in case of physics, practical science, what is this? In this case, it is not taken 61, it is 60. What is the meaning of that? We have to charge maximum 60 cells by this charging battery. When, sir, this is 60 cells, each cell is 3.3 volt. So what is this? 198 volt. Battery has maximum, what this 200 volt. If we take 61 cells, another cell will take another 3.3, that is more than 200 volt. It is not the answer. Therefore, what is the maximum number of cells? 60 cells. And when 60 cells are charged by this battery, how much potential difference is used? Will be used? Sir, 190 volt. What extra potential is here? Extra potential. Now, what is the answer? Sir, here answer is maximum number of cells is 60, not 55, 60, 61. Here may be 61. Okay? But this is not the answer. Answer is 60. Now, please be careful. I am deleting this part. Up to this, sir, here to here, what is this? Sir, this is 190 volt, and here to here, suppose I am putting, this is R, and this part will be what? Sir, this part will be only 2 volt. But what is this? So this is the charging current. That current is equal to 8 ampere. What is the formula? Sir, this V equal to 2, and this is IR. What is the formula? I into R, and this part is 2, this is 8, this is R. What is this R? R equal to 1.1 by 4 ohm. 1.4 ohm. 1 by 4, 1 by 2, 1 by 3, 1 by 4. Which is the answer? Sir, 1 by 4. I am repeating the question again. Here is charging battery 200 volt. N number of cells. Each cell is 2.5 volt, 0.1 ohm resistance, charging current. What is this? Sir, this charging current is 8 ampere. 8 ampere. Question is, what maximum number of cells can be charged? What is the rule? Since these cells are being charged, what is the formula? Here is 3 star. Be careful. Be careful. This plus sign, I am putting 3 stars for this plus sign. During charging, V equal to E plus IR. If you take, sir, this is minus IR, there will be wrong. E plus IR, this public is 3.34. Means each cell will take 3.3 volt to charge. I am taking n cells that equal to less than or equal to, not more than. This is equal to this. From here 60 point something, this is 70 point something. This is not 61. Maximum we can take 60. And when 60 cells are already charged, what is the formula? 16 to 3.3, 198 volt. Therefore, here to here, sir, 198 volt. Total is 200. This part is only 2 volt. This part is only 2 volt. Okay? And this is equal to VIR. What is that? R equal to 1.4 ohm. Okay? Please see here. This is R, this is R, this is R. Here to here and here to here. This part is A and this part is B. Okay? Question is equivalent resistance between A and B. Number 1 R, number 2 R by 2, number 3 R by 3, number 4 sir 3R. Be careful. Here this figure is given RRR, the equivalent resistance between A and B. Equivalent resistance between A and B. What is the rule? Please see, simple rule. First thing, I am taking R1, R2 and R3. R1, R2, R2, R3, these are I am taking simple for simplification. Now please next part is name the junctions. Second part is, sir, name the junctions. What is the rule? Name the junctions. I am naming A and B use. Therefore this is C, this is D, this is E and this is F. First take R1, R2, R3 equal to R. Second part, name the junctions. And third part, identify the common points. Identify the common points. Common points, what is the meaning? What is the meaning? Please see here. Here is no resistance. This part is no resistance. Therefore, A, C and E we can take. These are the common points. Take here common points A, C and E. C and E. From this side, so B, F and D. These are the common points B, F and D. Okay? Now please see here. R1 is where? Between C and D. Between C and D. This point is C and this point is D. R1. This is R1. Okay? Where is R2? D and E. D and E. Where is this? This is E and this is D. What is this? Sir, this is R2. R3. E and F. E and F. This is R3. Please see here. R, E and F. Now, this figure is now this figure. Can you tell me? From this figure, R1, R2, R3 in series, parallel and mixed combinations or series combination. What is the answer? Answer is all are same. What is the formula? In case of series combination, all are same resistance. Formula is RRR. What is the formula? R by N. In this case, sir, R by 3. Answer is this. Be careful. Answer is this. You can write like this. You can write like this. Sir, RS equal to R1 plus R2 plus R3. You can write this is R plus this is R plus R. This is, sorry, this is not S this is sir P. In case of parallel condition, parallel connection, what is the formula? Sir, 1 by Rp equal to 1 by R1, 1 by R2 plus 1 by R3. Sir, this is 1 by R plus 1 by R. What is this? 1 by R. This can be written as 3 by R, and therefore, what is this? Rp equal to R by 3. But suppose this is 1 by R, this is 1 by R, this is 1 by R. Sir, 3 by R. In case of all the resistances same, sir, R by N. Okay? Just simple. See here. I am doing here, sir, this is R1, R2, R3, R3. This is, what is the heading? Series connection of resistances. Please see here. Series connection of resistances. What is the meaning? Series connection, there are some special rule. All the current will be same. This is I. From here to here, sir, potential difference, total potential difference is V, but I is same for each resistance. Okay. Another thing is important. This V will be divided here. Sir, this is V1. Sir, this is V2, like this, and from it as this is V3. First thing, what is this V? Sir, this V equal to V1 plus V2 plus V3. We have to calculate final resistance, equivalent resistance. What is the meaning of that? Suppose this is A, and sir, this point is B. We have to calculate equivalent resistance. This is A. Equivalent resistance, first thing, sir, equivalent resistance, first thing, this is, sir, single resistance. This is important. This is single resistance. Okay. Another concept is, when this equivalent resistance, simple, this is R equivalent, but in case of series it is Rs, in case parallel Rp, and in case of mixed connection this is Rm. Equivalent resistance is denoted by Rs, in case of series it is denoted by Rp, in case of parallel, and in case of mixed connection this is Rm. First thing, this is the single resistance, and another important character is, when this resistance is used, all the three are not taken, but this resistance has the same effect as R1, R2 and R3 when used in together. R1, R2, R3 are used together, we are getting same current I, and here is same potential difference V. In this case, same effect without changing. Therefore, what is this? Sir, this is V, first thing, this is Rs, another thing is, sir, this is I. Can you tell me? What is, I am deleting this part. Sir, I am deleting. Sir, here V1 equal to IR1, V1 equal to, sir, IR1. What is V? Sir, IR2. What is V3? IR3. IR3. Can you tell me what is this V from this figure? Sir, from this figure, this V equal to IRS. Therefore, sir, what is this? Sir, this is IRS. From both sides, I will be cut. What is the formula? Sir, RS equal to R1, R2, R3. Okay. Now, I am giving, this is the rule. Now, I am giving, please write down this features of series connection or combination. First thing, I same for all resistances. What is the meaning? All resistances mean R1, R2, Rn and Rs. This is important. Suppose here are not only 3 resistances, n number of resistances. For each resistance, R1, R2, Rn and Rs, I will be same. Second part, this will be divided. What will be? sir, this will be divided. What is the rule? Sir, rule is, sir, from here you can write. What is this? Sir, this is IRS. This is IR1. This is IR2 dot dot. Sir, this is IRN. From here, what is RS? RS equal to R1 plus R2 dot dot Rn. I am deleting this part. Please see here. From here, what is the rule? From here, what is the rule? Sir, R, this part is very, very important. R is greater than Ri. From here, please see here. Rs greater than Ri. What is the meaning? Where, sir, where I equal to 1, 2, dot dot n, this I means individual. Individual resistance. What is this? This is the resultant or equivalent resistance is greater than any one of the individual resistances. In case of series connection, be careful. Rs greater than Ri. Here is another rule. What is the rule? Suppose R is greater than R maximum. What is the meaning? Out of this R1, R2, R3, suppose R4 is the R max, R4, the greater than Rs greater than R4. What is the language? Sir, equivalent resistance in case of series combination is greater than the maximum resistance in the series. Maximum. For any resistance it is greater, for maximum resistance it is greater. This is fourth. This is third. What is the fourth part? This is very, very important. What is the fourth part? Fourth part is, sir, R is, suppose all are same. All are same. What is the formula? Here to here, how many resistances? N. Suppose 3 are. N are. This is important. What is the formula? Sir, R is equal to, sir, NR. NR. Be careful. Next part is very, very important. For simple RS, for two resistances, what is the formula? This. For the two resistances, sum of the resistance. Equivalent resistance, simple, R1 plus R2. These are in case of series connection. Now please be careful. Sir, parallel connection. Parallel connection. First thing, what is the figure? This is R1, this is R2. I am taking only 3 first. Be careful. Here, sir, this is R1, this is R2, and this is R3. Here to here, first thing, sir, here V same. This is important. V same. Here is current I, sir, this is I1, sir, this is I2, and this is I3. All will be here again I. Okay? Suppose this point is A and this point is B. What is, sir, equivalent resistance this between A and B? I am taking this resistance is Rp. But what is this? Sir, this will be I, and here to here, sir, this will be V. Okay? Now, what is the formula? First, here V same, I divided, here is 3 star, here is 3 star. What is this? Sir, I is divided. Then what is the formula? This is the formula. What is this? I is divided. In case of parallel connection, I is divided. What is the formula from here? Sir, V equal to IRP. From here, sir, what is I? Sir, V by RP. Similarly here, I am writing. What is this? Sir, this is equal to V by RP, and this is equal to V same. V same. Same for what is this? Sir, R1, R2, R3, dot dot Rn, and sir, Rp. This is very, very important. What is this? Sir, this is V by R1, this is, sir, V by R2, and this is V by R3. Okay? Can you tell me what is the formula? I am deleting this part. Please be careful. Be careful. What is this? Sir, this is equal to Rp equal to 1 by R1. 1 by R2, 1 by R3. Okay, this is the formula in case of parallel connection. Now give the heading. What is this? Sir, features of parallel connection or combination. Be careful. First thing, sir, here first point V is same for all resistances. Be careful. All resistances mean, sir, R1, R2 ... Rn and son Rp. This is important. Second part is very important. Sir, I is divided. What is this? I2 ... Sir, I am not taking 3 only. I am taking n number of resistance, In. What is the formula? Sir, from here, sir, this is V by Rp, this is V by R1, this is V by R2 ... Sir, this is V by Rn. Sir, B same for all resistances. I am deleting. What is this? In this case, sir, general formula Rp equal to R1, 1 by R2 ... What is this? Sir, 1 by Rn. What is the conclusion? From here, third part conclusion is 1 by Rp. This is the sum of all this. Suppose I am putting one example. Suppose this is 100, this is 100 equal to 85, 80, 15 plus 5. 100 greater than 80, sir, 100 greater than 15 and 100 greater than 5. According to that rule, sir, this equal to sum of this. Therefore, what is the rule? Sir, R greater than any, in where I equal to what? Sir, individual. I equal to 1, 2 ... n. R 1 by Rp greater than 1 by Ri. 1 Ri. Please see here this rule. Now please tell me 1 by 2, 1 by 3, which is greater? This is 0.5 and this is 0.3. Sir, this is. But when taken like this, in this case, phase will be like 1 by 2 greater than 1 by 3. But when 2 is here, 3 is here, this is the phase. According to that sense, what is this? Sir, this is Rp. This is upper. Above, what is this? This is downward. What is this? This is Ri. What is the language? What is the language? Equivalent resistance. Equivalent resistance is less than any one of the individual resistance. Any one. Suppose R1, R2, R3. Out of this, suppose there is some smallest resistance. What is this? Rp is less than the smallest resistance. A smallest resistance in the parallel connection. Okay, this rule. Next part is very important. This is, be careful. Fourth part is, sir, 1 by Rp equal to 1 by R, 1 by R ... Sir, again, sir, 1 by R. Suppose how? 10 by R. N. If N is here, N, this is. What is the rule? Sir, answer is 1 by Rp equal to 1 by Rn. In case of parallel connection, this is the rule. Fourth, fifth, and that fifth part is very important. Be careful. Fifth part is very important. Only this. I am taking only 2 resistances. What is this? This is R1, R2. This is R2 plus R1. Now, please take an above. What is this? This is equal to R1, R2 divided by R1 plus R2. Easy to keep in mind. So, what is this? Sir, this is product and this is sum. Product of 2 resistances and sum of 2 resistances in case of parallel connection for 2 resistances. Simple product by sum. Okay. Sir, next part is, first thing, mixed combination or connection. First, here is one dialogue. What is this? First dialogue is, for mixed combination, sir, no fixed formula. or formulae, anything. Mixed combination, there is no fixed formula. I am giving one example. Please see here. I am giving. This is 10 ohm and this is 10 ohm and here is 20 ohm. What is the rule? Sir, these two are in series. What is this? 10, 10, 20. And this is what? Sir, question is A and B. And question is, what is this? AB is the question. Number 1, suppose 10 ohm, suppose 15 ohm, suppose 20 ohm, be careful, and suppose 25 ohm, no problem. Okay, what is the rule? Sir, these two are in series. What is this? Sir, this is 10 plus 10, 20, and this 20 and this 20 are in parallel, are both same. What is the answer? Answer is 20 by 2, answer is 10 ohm. This is what the answer. What is this? Please see here. These are in series. Series means this 10 plus 10, 20, and this 20 and this 20 are in parallel. What is the formula? Sir, when all the resistors are same, R by N, this is 20 and this is 20, are 20 by 2. 2 resistance, the 2 the resistors, so this is the 10. Okay. Now, I am discussing one question. What is the question? Be careful. Suppose I am giving 3 resistances, A equal to 10 ohm, B equal to 30 ohm and C unknown. Okay, be careful. This is question. What is this? A, B, C, 3 resistances. A is 10 ohm, B is 30 ohm, C is unknown. Here is one condition. What is the condition? Condition is A, B, C should be used in together. This is one condition. In together. This is one condition. Condition number 1. Condition number 2. Condition number 2. A, B, C can be used in any combination. And condition number 3, ultimate or final or equivalent resistance that will be equal to B, that is 30 ohm. These are the 3 conditions. Question is, sir, probable values of C. I am giving 22.5 ohm, 60 ohm, this is 60 and 120 ohm, and fourth 22.5, 60, or this is or